Okay, let me just immediately jump in. So here is the agenda. So we know that non-native speakers of English, and this holds for other languages, most of the errors they commit are about when they try to output prepositions along with articles. And this is estimated to be between 20 to 50% of all grammatical errors committed by non-native speakers. This depends on the language and on the domain, but this is explains a lot of what kind of errors we are making as non-native speakers. What we are after,
Noam,
yeah?
You have a black rectangle at the right bottom. I don't know if it's yours to close
that's
it.
You guys, that's the application. Is it okay?
Ah, sure. Great,
yeah.
Thanks.
Okay. So we are after a quantitative model that will try to model the kind of errors that our non-native speakers are committing. And we formalize the intuition that says that, you know, many times you hear non-native speaker output something, including for that machine translation system, you say they translated it literally. And literally actually mean that what they are doing is that they are producing the most probable translation. There is no such thing as literal translation. All it means is that it appears in most contexts, and this is what we normally call literal translation. So, and we look also at less likely translations, and we want to see how errors are going over there. So, okay, so for this experiment, we are looking at humans, at learners of English, as kind of little statistical machine translation. So machine translation in a nutshell is some kind of function that tries to maximize the probability. So we have our source text and target text, and we are having all these large corpora which are parallel, and we are trying to estimate the source given the target. It's a bit weird, but it's according to Bayes, and I guess most of you know that. It's just kind of a little trick. Intuitively, you would think it's going to be the other way around. So this tells you how adequate the translation is, right? So how likely an event in the target language is to occur given the input in the source language. And then what we want to see is that the target language output is fluent, how fluent it is. And this we can model for much larger corpora which are available in the target language. So we are looking here in this experiment in freshman students in a local college. Their native their native language is Arabic. So that's kind of, so to speak, the model in their brain. And they output sentences in English, right? So we want to look at this term here and to say how likely this word in English is given some model in Arabic. But of course, we don't have any access to their brain, so we do something else now. And of course, you can also see how the fluent their output here. If you look only, if you're trying to only model, to do a language modeling of the target language, but we won't touch on this here. So because we can't look into people's brain, not in my lab, so what we are doing is a translation experiment, and in translation we have access to the source text. So we sample hundreds of sentences from a parallel corpus, I will show you soon, and we are focusing on the most frequent prepositions in Arabic, namely fi, which is equivalent for the preposition be in Hebrew, babait, and we look at different translations. In particular, we look at cases where it's translated into in, which we all expect, right? That's the literal translation or the most probable. Where it's translated to nothing, null, I'll show you some cases. Where it's translated to at, like fil maktab, and then you'll have at office, and of, and on. So there are different options to translate it, and there are many more actually. What we did is we collected 20 sentences and we created an artificial uniform distribution. So we gave exactly the same chance for every translation to occur. So what you have to imagine is 20 sentences in Arabic. All of them contain have the word fi in it. And the good translation, so to speak, the professional translation is one of these words appearing 4 times exactly over 5. So it's a 4 by 5 matrix, let's call it this. And we asked 45 Arab students, Arab only refer to L1, to their native language, to translate it from their native tongue into the learned language. And they all have fairly good English. They are first-year students in college. And since the translation has the same chance to appear, it's equiprobable, we can compare what they actually did to this uniform distribution. And we want to see how they are biased by more probable events. We want to see how likely they are to select less likely translations and whether their performance deteriorates as a function of how rare a word is, like the translation, I mean. So, okay. So here are some examples. So all I want you to look at, for those of you who don't speak Arabic, is that the word fee appears in each and every sentence here. So you can imagine 20 such sentences. And here it's translated into on, and here into of, and here into nothing, and here into to. To is, by the way, we had it in the experiment, but 2 examples were pretty bad, so we just discarded them, which is a shame, because there are very nice examples. So in a verb like contributed to in Arabic, yusahimu fi, you have this in translated into to, so to speak. And when I'm saying in, I'm referring to fi in Arabic. Is it clear so far? Okay. So how do we estimate the translations of these? So we collected this fairly large corpus taken from the UN and from news translations. We have well over 8 million sentences of Arabic translated into English. And we, due to the exactly things that Ru'u talked about, Arabic is also morphologically rich. We use Farasa, we want to segment it such that we make the alignment accurate, because fi, for example, can get some suffixes, whereas needless to say that prepositions in English cannot get suffixes. We do the same trick for English with its poor morphology, so, but it's a preposition, so no inflections here for English. And we use a pretty standard alignment algorithm to produce the alignment between phi and the different candidates. And what we get is this kind of distribution. So what you see here on the x-axis is the prepositions that are translated, translations of the word phi, and the probabilities they are assigned given the training data here. So what you can see, not surprisingly, that the word phi is translated like 41% of the time into in. This is what we normally call its literal translation. Then it's translated into nothing around 29% of the time, and then it starts to be very low probabilities. But importantly, these are the only translations which are valid in certain contexts. So although they are rare, again, if we are going to look again here, it's not that it's rare for phi to be translated into to, but you can't do anything else if you want to use this verb. So, and there are many more actually. So, and this is a challenge for learners as well as for machines. So here is another equivalent, because machines are actually learners as well, if you want to flip my metaphor here or the analogy. And let's look at some results. So I'm giving you the total of all the 45 tests that for the 45 students. So what you see here in the diagonal, it's practically a confusion matrix. So if the correct answer was in and the correct answer is in and students wrote in, you could see they barely make mistakes, only 6% of the students. When it has to do to translate this preposition in Arabic into nothing, they perform even better. And then when they have to produce at, of, and on, you see it's going down. And another observation here, which we'll touch on in the next slide, is that you may ask yourself, so what they are using instead? So if the correct answer is in, what you see is that they are mostly using at, of, and on, right? So they had to put at office is a good example, right? They had to put here at office. Whenever they had to put at, they were wrong 44% of the time, or they were correct, sorry, 44%, no, it's 44 they were wrong, sorry, it's erroneous answers. And what they did is that they went for the most probable event. So if you don't know anything, that's kind of a good card to play, right? Like if you think of it as a rational decision. And so, as I said, like we are having 94 and 98% accuracy when it has to do with very probable translations. When it has to do with less probable translation, like at and of and on, then they are going to perform less well. And the preposition in accounts for most of the errors. And generally, the less likely a translation is, the more errors will occur, right? So like you can see it here. And there is another interesting observation. So when a student is not very good, they are mostly going to go for in. Our top favorite student actually is the one who did in all of the translations. She just put in. So, you know, that's what she did. Probably didn't know much, and it was a fair bet. But when you start to have doubts, when you learn more English and you say, well, I know in some cases it's going to be at, but it actually has to be in, then you're more prone to make these errors, even with high probable events. So, like, because you have more options now to select from, you're going to commit more errors, even when the answer is, so to speak, trivial. And lastly, well, I think we can see the translation models provide a good explanatory, sound explanatory model for learners' error. These errors reflect interference from their native language. We don't know yet how to go about how to use this model for freely produced text, but for a first shot, we just wanted to look at it in the lab and to see how it behaves when people translate from their L1 into their learned language, L2. And there is just another point for the industry. It's not really my domain in this, but to the best of our knowledge, most writing assistants, such as Grammarly, they ignore completely the L1 of the writers, right? So they don't ask themselves who is there committing the errors and what kind of errors they are likely to make. And we have the intuition that maybe looking at this metadata of who the users are can assist in giving better recommendations for non-native speakers. Thank you very much.
Thank you, Noam. Very interesting.